Hello, my name is Jack Scrable, and my project for CS677 is a music recommendation engine. So the objective was to create a music recommendation engine using data from the Million Song dataset, which was compiled by the EchoNest, a music machine learning company that was actually bought by Spotify and based in Somerville. The method I'm going to use is the deep learning feed-forward neural network, which is augmented by a k-means classifier. I wanted to see if it would improve the training time and test the accuracy. These are the goals I set out to hit when I started the project. They're pretty straightforward. Basically, I'm just making sure that I can take an input from a user, classify the user's songs, and output a recommended song. So those two things are definitely distinct processes, and I'll get to that later in the presentation. And then lastly, I wanted to observe the difference in output between the raw neural network and the neural network plus the k-means classification. First, let's talk about pre-processing. That was an integral piece of the design because it was incredibly complex, the source data. It was stored in HTF5 files, it's hierarchical data format, and there are many different types of data. So I had to make a ton of decisions about how best to represent this information, taking into mind the efficiency of the network and the representation of each data point. So this is a flowchart describing how I chose to do all of that pre-processing. You can see that it's separated by color. The green is used primarily in pandas, yellow was NumPy, blue was scikit-learn, and red was Keras. Two interesting parts from this, you can see lower in the flowchart. There is the numeric and then multidimensional section. So that's for the raw audio data. There were sections that had samples from different points in the pitch at each different time. So it ended up being a multidimensional matrix. So I had to basically normalize all of those and sample specific points from each of them in order to normalize the size of the arrays. Another interesting piece is that I normalized the entire data set individually by column first, then stacked them all together into a matrix, and then using the scikit-learn robust scaler, scaled the entire matrix. I had to do that because the neural network was stalling around 20% in the testing validation. When I did this, it increased to about 45%. After the scaling, that's when the k-means classifier would be added and then moved on to the neural network. So next, let's talk about that neural network. The final input matrix had 572 columns. That did vary depending on the number of songs that were chosen to go in and how choices were made around the pre-processing, especially on that raw audio data that we were talking about earlier. And then basically, the neural network has an output layer with 18 neurons classifying into the labels you see on the screen now. That uses the softmax activation. So if we look at the structure of the neural network, you can see some sample input data coming out on the left. Note the k-means cluster on the bottom. That would obviously only be there using the augmented neural network. X's represent dropout points, which prevents overfitting. Green nodes indicate batch normalization, which again prevents overfitting. I was having issues with overfitting the network to specific pieces of data. And then you can see the output layer uses that softmax. So the best part about softmax is that it outputs a floating point number between 0 and 1 for every one of those neurons for each piece of input data. So say I put in a song and it has a 0.9 for rock, 0.5 for hip hop, and then a 0 for classical and jazz. We know with most likely that song is a rock song. But we will use those other probabilities later on when creating the recommendation. So on that note, let's move into the demo. So what I'm going to do is open up the app. So here is the music recommender app. You can see on the left, I have both the simple HTTP server running, serving the HTML, CSS, and JavaScript, And then I also have the API running on Flask. So you can see it, I hit it at this lookup endpoint right now. So that will allow me to look up different songs. So let's try this right now. If I choose this song by The Clash and hit get recommendations, now you can see the Flask API did a bunch of things here. It grabbed the song, it pre-processed everything, and then it sent it to the model for prediction. So it classified this into the genre of alternative, which I think is pretty fitting. And then you can see the information about the recommended song down here. And you can see the endpoint that was hit as well. So recommend with the song ID. And this is a surf rock band from the 80s. So I think that's a pretty good recommendation as far as the Clash goes. Let's try again, see what happens. Okay, so KMD is a rap group from the early 90s in New York. Let's see what comes out there. Decent recommendation. This is another rap group from New York in the 90s, a little later, a little bit of a different subgenre, but still not too bad. Let's see what the API was saying. So this is wrong objectively. It's not, this wouldn't be in the genre of metal, but it still did recommend a good song. And that was achieved through a process that I'm going to talk about in the last few slides of the presentation. So let's go back to that. So just to talk briefly about what didn't work, as I was saying before, the data was difficult to work with. And because it was such a large number of columns, it was hard to work with any more than 10,000 songs at one time on my personal machine. So it was hard to train on any significant volume for what was a pretty difficult problem. So that definitely affected the final level of accuracy for the neural network. And I was only able to get about 50% accuracy with classifying into those manufactured labels, as we were talking about before. What did work is interacting with the model through Flask and Keras. It ended up being pretty straightforward. I could just load the model into memory as soon as the web app was loaded. And then, as you saw before, any recommendations go pretty quickly and send it right back to the user. And what's happening there when choosing the most similar song according to the model is every time then a new model is created, I run every song that I have at my disposal through the model and save off their list of 18 probabilities for each of those 18 classes. And then when a new song needs to be recommended, that new song is run through the model again and then compared to that classification probability history file to find the most similar song in terms of root mean squared error from all of the other lists of probabilities. So what that does is allows us to find a song that the model thinks is similar to whatever is coming in, even if the classifications and the genres that we're actually putting those probabilities in for might not be the most accurate. And then finally, the hybrid k-means approach with the neural network does seem promising. So if you look at this graph, the red line is our k-means augmented neural network. And as you can see here, it starts to jump out ahead in terms of training accuracy in front of the standard neural network. They do fall back together a little bit here towards the end, but I think that can be attributed to the neural network overfitting a little bit, because while this is the training accuracy, the testing accuracy wasn't quite as high on this run. So that's the final product there. So that's the end of the presentation. One thing I will do is run the neural network on a smaller scale so you can see how that actually runs. So here I'm going to run the process of training their neural network on a subset of about 200 songs. So if I just hit enter there, this will start running. So this is going to read those songs from those HTF5 files we talked about earlier. Then it's going to start pre-processing those songs and then actually run them through the neural network itself. Now, the accuracy for the neural network will not be very effective in this instance because we're only using about 200 songs for what is a relatively complex problem. So here you can see it's vectorizing, putting it into a matrix. Here you see the size of the network. Here you see TensorFlow starting to run and try to train the network. And you can see the accuracy is not improving that much. Might only get up to 20 or 30. Another important thing to note here is the difference between the loss accuracy and then the validation loss and the validation accuracy. So the validation loss is not being trained on. So that's a good sample of what the test accuracy will be next. Here in between, we're running the k-means classifier and then trying it again with that slightly augmented neural network. The accuracy does seem to be getting a little higher here with the k-means, so you can see how promising that would be as an approach when using more data. And here we have a plot of how everything fared. So it does look like our loss got lower there towards the end when using the classified version, but only marginally. And again, that's probably because of the small data set. It's really inconsequential in terms of this neural network, but I just wanted to show how everything worked. Okay, and that is the presentation. Thanks for listening.